Hello, my name is Muhammad Takar Shaiman. So I will present about the question three that asking about the classify the modification needed to reduce aerodynamic drag and increase fuel economy. So here we can see to reduce aerodynamic drag and improve fuel economy, several vehicle modification can be applied. Firstly, the body shape of the vehicle can be streamlined to allow smooth airflow. This include using rough edge, smooth surface, and avoiding sharp corners that disturb air movement. Secondly, the underbody can be covered with the flat panels to minimize air turbulence below the car, and a rear diffuser can be installed to guide the airflow out smoothly. At the front, the grill opening can be minimized, and the air dam or splitter can be added to reduce lift and improve stability. At the rear, adding the small spoiler or tapering the vehicle shape can reduce drag caused by air separation. In addition, wheel covers and low rolling resistant tires can help improve aerodynamic further. By applying this modification, the vehicle experience less air resistance, which means the engines required less power to move at the same speed. This result is better fuel efficiency and improve overall vehicle performance.
Hi, my name is Muhammad Azizan and I would like to present about my case study for question 4. So the question 4 is needed to use tire data calculator on the BND Texas, that is the website that we given after we put our tire, the details. So the details that we get is stiffness rate is for Rate is for 20.9 kilogram per mm. Then we must convert it to Newton meter. At this we get 205,029 Newton meter. So how to convert it is 1 kilogram is equal to 9.81 Newton and 1 mm is equal to 0.001 m. So this is how we convert it. For the suspension stiffness, we use the formula that is K equal to 4 pi square m that we get from the question, that is this one. That is, we put everything. So the M is the mass of the car that we can see from the catalog over here. That is, yes, this one. This one. So we just put it inside the formula. So after that, after we put it inside the formula, we get it, the answer. So to find the first one is the front and rear axle rate. We use the formula is right rate equal to Ks Kt over Ks plus Kt. That is Ks equal to suspension stiffness and Kt is for tire stiffness. We just substitute the value that we obtain inside the formula given, and then this is the answer. And for front and rear axle nature frequency, we use the W and equal to right rate over mass and inside the square root. So the M is about mass. So for the answer is we put the right rate answer inside the square root over the mass of our car. So this is what we get, 9.89 hertz. So for the question 5 is about Ackermann geometry illustration. So this is the formula used, that is tan L over R, which is L equal to wheelbase, R is turn radius. So our turn radius, like for our wheelbase is 2440 millimeter. We convert it to 2.44 meter. For the turn radius we got is 5.6 meter from the catalog we given. And the track we got is 1460 mm. We convert it to 0.146. So the inside steer is we use tan equal to LR, that is this one, and the outside is L plus T over R. We plus it because we include the number of the outer turn radius. So this is how it's look like. It is for the inside one is about 23.54, and then the outside one is 34.85 degree.
So for question 6, they're asked to answer, break down the advantage and disadvantage of tire changes based on a review of a tire specification. So changing tire specification can affect vehicle performance, safety, and fuel consumption. The advantage of a changing tire include improving handling, better grip on the road, and enhanced braking performance when using wider or higher quality tires. Certain tires are also designed for better weight grip and cornering stability, which can increase safety during high speed driving, or in wet condition. However, there are also disadvantages if the tire specification does not match the manufacturer recommendation. Using wider tire can increase fuel consumption due to higher rolling resistance. Incorrect tire size may affect the speedometer reading and cause uneven wear on the suspension component. In addition, performance tires may wear out faster and produce more road noise compared to standard tires. In conclusion, the tires changes should be always be made based on the correct specification set by the manufacturer. Choosing the right tire help to maintain comfort, safety, and fuel efficiency while preventing premature damage to other vehicle components. So this is our conclusion. The Proton Satria 1.8 GTI is a well-balanced performance hatchback. It has a sporty, stiff suspension for agile handling, a strong engine capable of high tractive force in lower gears for good acceleration, and a correctly designed Ackerman steering system for stable cornering. The main trade-off in fuel economy and ride comfort, which typical for a car of this character. So this is our recommendation of for improvement. We have a three. So first one, for aerodynamic and fuel economy, implement the modification you classified. Priority, add a front air dam and the body panels to reduce drag at high speed, improving fuel efficiency without heavily impacting the car's sporty look. Second one is a four tire selection. Stick to manufacturer spec. When replacing tires, choose a high performance tires in the original size to maintain the correct gearing, speedometer accuracy, and balance handling you calculated. Last one is a for performance tuning, which is a focus on grip. So the car has a strong acceleration force. To best utilize this, consider upgrading to limited slip differential and stickier tires to improve traction and reduce wheel spin, especially during hard acceleration. So that's all from us. Thank you.